This video is for section 7.7 in our Algebra 1 distance learning curriculum. It is called the zero product property. This section is really kind of fun. So far in Algebra 1, when you've graphed stuff, we've done a lot of linear graphing. So like y equals x to the first power always gives you some sort of a straight line. But now in chapter 7, we've been doing a ton of things where we end up having x to the second power happens. And if you plug that into Desmos, you'd see you get this kind of cool U shape. If I could use this pen better, that would be a lot better of a drawing. And we're going to spend some time today in here with functions that have an exponent of 2 and some things that are going on in their graphs. So if you take a look at this one for a zero product property, please notice we have y equals x squared, so you can see the U shape on the graph. Let's kind of center ourselves a little bit, and please notice that right here is our x-axis, and right here is our y-axis. And then you can see the parabola. Now, when we use the zero product property, the thing it's actually looking for is where the parabola crosses the x-axis. Those points are going to become more important as you get further into your math career. But for now, we're just going to get used to how in finding them. So what's happening here in the zero product property, you're looking for these x-intercepts. You're looking for where your graph crosses the x-axis, which is this left to right one. So your answer for a problem like this, you'd say, well, for the zero product property, x equals -1, because from the origin, we went 1 to the left to get to this guy. And then this one over here, from the origin, we go 1, 2, 3 to the right. So that would be an x equals 3. So for the zero product property, to find the x-intercepts for this parabola, there are 2 of them at x equals -1 and x equals 3. Let's look at this again. Now, all of a sudden, you might be familiar. We've been dealing with trinomials like this a lot. After we do the area model, we've ended up with things like this. And now we've recently just started looking for common things to factor out or break apart. What you're going to learn really soon is that this polynomial gets broken apart into y equals x plus 4 times x plus 2. If you were to put x squared plus 6x plus 8 into Desmos, you'd get this nice parabola. You know there's a parabola because of the x squared. If you also put this, y equals x plus 4x plus 2 into Desmos, you'd get that exact same parabola. And now the zero product property, if you remember, is saying, well, what happens, or where are the x-intercepts? So if you'll remember, if we'll ground ourselves, again, here is the x-axis on our picture, and it looks like the y-axis is over here. So you have your x and your y. And when I'm looking, it looks like this parabola crosses the x-intercepts here and here. Now the question is, though, why did we rewrite it instead of a y? Why did we put a 0 there? Well, think about it. Anything on the x-axis, this is 1, 0. This is 0.4, 0. This point right here is a -2, 0. This guy is a -4, 0. What do you notice they all have in common? It's that when you're at the x-axis, the y value is 0. So that makes sense. When the y gets changed to a 0, that's a huge clue that they're asking, where does the parabola cross that x-axis? So we can look here and see that that happens in 2 spots. So you can see it crosses at x equals -4. That's from the origin. We count 1, 2, 3, 4 to the left. And then there also is another x-intercept at x equals -2 because we count from the origin 1, 2 to the left. Now, here's a weird thing though. What do you do if this picture is not available to you? It's super nice that it is because you can just look and see where the parabola crosses the x-axis. But to use the zero product property using algebra, it really is not bad at all. All you do is you take both of these binomials and set them equal to 0. I want to know what's happening when x plus 4 equals 0 and I want to know what's happening when x plus 2 equals 0. So now just solve for x. Put in your railroad tracks. To solve for x here, we subtract 4 from both sides. I get x equals -4. And on my second equation, railroad tracks, subtract 2 from both sides, I get x equals -2. So if you take a look, x equals -4, well, we saw that right here. And then when you've got x equals -2, we visualize that, we saw it right there. So to use algebraically the zero product property, it's really pretty simple. Take both both polynomials, in this case it's a binomial and a binomial, set them equal to 0, and then solve for x. Let's try another one. So here we don't have a picture. I can't just look and see where the parabola crosses the x-axis. My clues on what to do is it tells me use the zero product property. And then I remember that this would be rewritten with this y would have a 0. But instead of y, it's a 0. So I'm looking for where it crosses that x-axis. So I'm simply using the zero product property, set both of these binomials equal to 0, and then we'll solve for x for both of them. So I put in my railroad tracks. To solve for x on the left, I add 5 to both sides, so I get x equals 5. And to solve for x on the second equation, I subtract 3 from both sides and get x equals -3. So those are going to be your official answers. There are 2 for this problem. If you were asked to make a sketch of it, let's just visualize this. Oops, that's not what I meant to do. There's my y-axis, there's my x-axis. It's telling me my parabola has x-intercepts at -3, so I'm going to count 3 to the left. And then I have one at +5, so I'm going to count 5 to the right. So I don't really know what my parabola looks like, but I do know it passes through those 2 points. If you wanted to make a sketch, you could make your U-shape, I don't know, something like that. But what we are looking for are these 2 guys right here. I'm using the zero product property. All right, last one for the day. X plus 2 times the quantity of x minus 4 equals 0. It tells me to use the zero product property, and that equals 0 clues me in that I'm looking for the x-intercepts as well. I don't have a picture, so it's not going to be too hard to do this algebraically. I have an x plus 2 equals 0. And an x minus 4 equals 0. We're going to put our railroad tracks in for both and solve for x. So on the left, I subtract 2. So I have x equals -2. And on the right, I need to add 4. So I get x equals a +4. So those are my answers using the zero product property. I think it always helps to visualize what it's telling you, though. It's saying oh, I did it again. I get so excited. If you have your x-axis here and your y-axis here, that equals 0 wants to know the x-intercepts. It's telling us, our first answer tells us we have one at -2, so from the origin, I'll go 2 to the left. And it says we have one at x equals +4, so from the origin, I'll go 4 to the right. And that's where my parabola crosses the x-axis. Those are the x-intercepts. So if I wanted to kind of sketch in what I think this U-shaped parabola will look like, maybe it'd be something like that. But remember, for the purpose of this assignment, these are the answers you're looking for, and this is the work we're looking for you to show. You can always go on to Desmos.com, plug this in, but instead of equals 0, you can write in equals y, and then visualize and see if you got the right answer. All right, so I'd love for you to practice a few of these. There's a short homework assignment on Schoology. You can either print out or do on your own notebook paper, and please turn it in. We are here for you. We want to help. Please reach out to us if you're stuck. Have a great day. See you next time.